Hello and welcome to the final episode in our Gamepad widget series. In this series we've gone over how to create a widget interface that interacts with both the keyboard and mouse as well as a gamepad. So lastly we did a quest screen, and what we're going to do now is take a look at a map screen. Now the whole purpose of this series was I wanted to show you various different types and interfaces and how you can control it with the mouse and the gamepad. So the map is the last one I'm going to show you, and that is a scrollable image that can be controlled again with mouse drags as well as the gamepad. So without further ado, let's begin. So I've got my already imported in my map. I'm just using one from Fortnite just for demonstration purposes, and obviously you design your map for your level and do the artwork for it to look as good as you want it to look. You want to obviously try and keep it to a power of 2. So here I've got 1024 by 1024. So you want to keep it to a similar sort of size. Okay, so first thing to do is make this into a material. So right click on it and let's create a material. And we'll call this map screen mat. And I'm going to open this up. So the way this works is going to be very, very similar to my advanced minimap series. If you haven't seen that, check it out. We use the exact same method here as we do there to get a scrollable map. So the way this works is we basically render only a part of the image and we change it using parameters based on inputs that the player is doing. So first thing you do is change it to be a UI element. So click on the main brown node here. Go down to the left hand side where it says material domain surface and change that to a user interface. That now means that this can be used for a user interface. And we can plug in the final color there, like so. I'm going to hit apply and I'm going to close that. We'll be coming back to that obviously in a moment, but first of all let's just put it into our map screen. So here's my player menu map screen, which we just had the text on it, and in here I'm going to put a scale box. So a scale box is a type of panel that we drag into the canvas panel, and we want this thing to fill the whole entire screen. So I'm going to go to my anchors and set the fill one, and change my offset to be 0 and my offset bottom to be 0 too. Hit compile. Inside the scale box we're going to drag in our image from the palette. And on the image we want to set it to our material. So find your brush and choose the image for your map screen mat. And there it is. So this thing needs to be scaled to fit the whole entire window. So with the scale box selected, scroll down, you'll see stretch. And we want to choose the scale to fit X. And what that'll do is it'll scale it until it fills up the X, clipping top and bottom off. We want to do that in this case because our screen here is wider than it is higher, so we want it to clip off the top and bottom. Hit compile and we're done there. So now we've got this on our screen. Oh sorry, you can actually get rid of that text now. Now we've got that onto our screen, next thing to do is work on the inputs and set up the parameters. So let's begin by setting up the parameters for our material. Go to Add New, Material and Textures, and Material Parameter Collection. Map Screen, Parameters. We're going to open this up and we're going to add 4 scalar parameters. The first one is going to be called X. The second one is going to be called Y. And both of those are set to a value of default value of 0. Then going to add a third one called zoom, and the default value for that one is going to be 0.5. And we're going to finally add one last scalar, and the name for this one is the dimensions. And the default value for this is going to be 1024. Hit save. And what parameter this asset does, it is a way of storing values that you can be used in the material. So if I go over to now to my material that we made earlier, we can now import those in here like so. I'm just going to type in here parameter, and you should see collection. There you go, collection parameter. And on the left hand side details panel, with it selected, you can change which collection it comes from. So we want the map screen parameters collection. And then you choose from the drop down which parameter it's going to be using. So we're going to use the zoom first. And whilst I'm here, I'm going to duplicate this and set this to all the other ones as well. So dimensions, X, and Y. So first thing we're going to do is we're going to take the texture coordinate and we're going to multiply that by the zoom. Now the zoom by default is 0.5. It'll be a scaling value between 0 and 1. So basically 0.5 means it'll take the texture coordinate of 1 times by 0.5 equals it gives you a 0.5 end value. Meaning the UV coordinate will go up to 0.5, which is about halfway. So it's going to show us this top quadrant here. So if I now plug that into there, you should see it shows us the top quadrant. Okay, so that's what the zoom does. Next, we're going to get the coordinates, and these will be the coordinates of the center of the screen. So what we need to do here is work out what the x-coordinate is in relation to the dimensions of the screen. So we're going to take x here and divide it by the dimensions. So if x is say 500, it'll be 500 over 1024, which will give us the coordinate on this texture here. We'll do the same for y. So divide that by dimensions there too. So with the coordinates now set to a normalized value, which is what this is doing, onto the texture. Normalized being this will give you a value between 0 and 1, so it'll give you basically a relative location on the texture of where these are. What we want to do is we want to apply that to the zoom, okay? Because the zoom will change the location of the coordinates a lot, okay? So first thing we need to do is we need to divide the zoom by the number 2, so you get the halfway point between the zoom. So for example, if I plug that into there, you'll see I've now got halfway. Okay. So next, I then want to subtract, and I want this divide here to go into the B pin, and the A pin is going to be 0.5. Okay. And this is going to be our offset, and we're going to apply that offset combined with our coordinates here. So we're going to add our coordinates together to this offset. We're going to go add like so, and add that together like so. So now we've got an x and y coordinate. We need to combine these together to get ourselves a total UV. Okay, UVs are two-dimensional coordinates. So drag from the top one, and we're going to type in append. Plugging in your bottom one into B. So now you've got a two-dimensional vector, which we can now use as our UV here. But before we add it to the UV, what you want to do is take the append vector here, and we need to add it to our zoom, which is this line coming out of here. Now the reason why is because this is just working out the offset based in relation to where the zoom currently is. So what we need to do now is add that to the zoom's current position. So we go add to there to now move the zoom to be where the x and y is. Now because x and y are set to 0, 0, we want 0, 0 to be, well, 0, 0 is in the middle, and it's to be defined that by using our offsets here. So what will happen now, if I plug that into UV, is now we get dead center of the map. And the reason why we get dead center of the map is because we've defined dead center to be 0, 0, okay? That's what this is doing. And we're adding it to these dimensions here, and to the zoom here to offset the zoom. Okay, so that's now gone into the texture sample like so, and that is it. Oh, one thing you could do is to make sure you don't get any weird glitches. We can clamp this value here, between 0 and 1. Okay, we leave it at 0 and 1. That will stop the UV from repeating and going on forever, no matter what happens. Okay, and that's kind of it. We're kind of done there. So let's apply that and save. And now let's take another look at our map UI. And there you can see it's reflecting the change we made in the material editor. Okay, it zoomed in to the middle at twice the zoom. Okay, so now we've got to work out the code for this to scroll around with left mouse clicks and the gamepad. So let's first of all focus on just the left mouse click. So I'm going to go to the graph, and we need to set up a few things here. Now the first thing we need to set up is we need to set up all the parameters that we made in our material parameter. So we're going to do that in the tick event. And the reason why you're doing a tick event is because you're going to be constantly checking and updating the X and Y coordinates, zoom out coordinates, and all sorts of things. So it's easy to do it in the tick. And in here, we're going to set parameter, and it'll be set parameter value. Yeah, there you go. Set scalar parameter value, choose your collection, and then choose your parameter value. So here I'm going to do dimensions first, and I'm going to type in the size of my image. I can type it in, or I can drag the image in and use its size there. I'm just going to type it in. That one won't change that much. You just want that to be as is. Next, we're going to copy and paste this multiple times, one for each value. So this first one, going to do a second one. So we're going to change that to X. Second one to Y, and last one to zoom. Now we need values to go into these parameters, so I'm going to make some variables up here, and we're going to call map X value, and that's going to be a float. And we're going to make another one, map Y value, and finally map zoom value. And these are variables because these are things that will be changing throughout your game. So I'm going to drag my map X value to X, Y value to the Y, and zoom to the zoom. Okay. And hit compile. So as I said, we're going to work on our mouse inputs first. So go to the left hand side where you see functions, and go on to override. And we want to use mouse button down. On mouse button down, we're going to tell it that we're going to start dragging this map around. So on the variables here, I'm going to make a new boolean called is dragging. Then on mouse button down, I'm going to drag is dragging out, called set, tick the box, and plug it into the end there. Now this will work with any of the mouse buttons, left or right or middle. What we want to do is make it so it only works to the left. So with the mouse event here, we're going to drag out and go is mouse button down, and we're going to choose the left mouse button. That's the key we're going to check. And this return value we can drag straight into the set there, like so. Now at the end of each of these inputs overrides, we need to tell the return value to handle it, and that will stop the input from carrying on down the chain. So that's mouse button down. Mouse button down. Whilst we're here, we'll do mouse button up. So we're going to go override on mouse button up, and it's basically the same. So we're just going to tell it to drag is set its dragging, and check the mouse event is mouse button down. I know it says down, but it still works for the up in this case because it is an up event. We go left mouse button, plug that into each dragging, and again tell it to be handled. Okay, so there's our drag event. Next we're going to do is make it so that when we move the mouse whilst we're dragging, it changes the map X and map Y values. So override, and you will look for on mouse move, and we want to put a boolean branch in there to check if dragging is true or not. Okay. Now here comes the maths part. We want to get from the mouse event the delta. So get cursor delta, and the delta basically is how much it's changed between the last tick and the current tick. So how much has it travelled. Okay. From that, we're going to get the X and Y values. So I can split this to get mouse X and mouse Y. Now, in my tests, I found that we need to multiply these values to get it to move at a good speed, because by default it's quite slow. So we're going to multiply this first of all by a float, and we'll do 5. And we're going to do exactly the same to the Y. And we want then to get the map X value here, and we're going to add a float there, and we'll do the Y value as well, exactly the same. Add the float there, like so. Let's set me off, that is, put that way around. So we've got those two values. So we've got the changes being made. We now need to just set that to the new values here. Before we do that, we're going to clamp these so it doesn't go off the screen. So I'm going to go from here, clamp, float. And the min value is going to be minus 512 and positive 512 is the max. And you'll notice that that is half of 1024, which is our dimensions. So we'll take that, and I'm going to copy paste this in the bottom one as well. And now we can set those values to map X value, set, map Y value, set. Plug those all into the true branch. And again, put in handled on the end there. Hit compile, and let's test this out. So I push tab, go to the map screen. What's happened here? Now, I know what's happened there. We'll go into our map UI again, and our zoom, you'll see, we didn't change its default value above 0. So it zoomed in basically to just a pixel. So we're going to change that to 0.5. Hit compile. Now let's test that out. Hit tab, map screen, and there we go. I now can left click, I can drag it around. Now as I drag around, you can get a feel for which way you want to drag. It's up to you. At the moment, mine is 1:1 in the X, so if I move the mouse left, it looks like it. I think it pans left good, and pans right well. Up, pans up, and pans down. If you want to inverse it, you can more than welcome to. The way to inverse it is you just multiply it by -5 rather than +5. Okay, it's down to you and your preference. Okay, but I'm going to leave mine as is. I'm quite happy with that. So now we've got the dragging with the mouse, we're also going to do the zoom. So let's make a new function on here, override anyone on mouse wheel. So on mouse wheel, it works fairly similarly to everything else, it's not too difficult. We're going to get the mouse event here and get the delta. And we're going to multiply this by a float. And this is going to be the value that we want to change it by. So in here, I'm going to do -0.1. Negative will make it scroll in the correct direction. Okay, if I move the scroll wheel up, I want it to zoom in, not out. Up is going to increase the value, which will make it zoom out. So making it zoom in, I'll do it like that. So once we've got that, we now need to set that to a new map zoom value. But before that, let's clamp it first. Clamp float. And I'm going to clamp it between 0.1 and 1. And 0.1 because I don't want it to do what it did before where it zoomed into just 1 pixel. Okay, I always want it to have a little bit of gap. And we're just going to set that back to map zoom value. Like so. Oh, apologies, I forgot to add it to actually the zoom value that we currently got. We're changing the current value. So get your current value and we're going to add it to a multiplied one there, and then plug that into the value of the clamp. And that should do it. And the return value here is going to be handled. Hit compile, close this, and let's push play. Now going to the map screen, I can zoom in and out with the mouse wheel and drag around the screen. Perfect. So the last thing we need to do is get working the gamepad. So let's get started with that. Unfortunately, it's actually a bit easier. So we want to go to the functions and override again, but this time we're overriding on analog value changed. And this basically means whenever any analog value on your controller, that is going to be the sticks or the triggers, this will trigger. Okay, this will come into effect. So first thing we need to do is set up here is we need to get the input event here and store it, as well as storing the analog value that's coming out of it. So let's come out of here and get the analog value, and I'm going to promote that to a local variable. And this is going to be the analog value. Plug that in, and we're also going to get the key event. From the event, we're going to get the key, and then we're going to promote that one to a variable, a local variable. We'll leave it as key. Next, we're going to do is we're going to go and create a sequence, because we've got a few things to check here, because this is going to work for all the keys we're going to need for our gamepad. So it's all going to be on this one function here. Let's give ourselves some space with that return node out of the way there. So on the first one, I'm going to do is check the x-axis on the gamepad. So I'm going to drag the key out, get key, and check if it's equal to the gamepad left axis, gamepad left thumbstick x-axis. And this will give us a boolean, which we can put into a branch. Okay, and that going to then 0. The true branch of this is going to take our analog value, multiply it by that 5 that we done for the mouse, exactly the same here, and then we're going to drag map x value here and add it to the float that we've just got. We can then clamp it, just like we did with the mouse, to minus 512 and 512, and then set that back to map x value. And it goes in like so, and we can tell it to be handled. And that is the first one. Okay, now the next one is going to be basically the same, so I'm just going to copy all of this and paste it underneath. Then one is going to go into that branch there. This time we're checking the y-axis. So gamepad y-axis in the left thumbstick. And it works exactly the same, except we want to do it to the map y value. And we want to set the map y value. Like so. Then we've got our zooming in. Ooh. So if I then add another pin here, and we're just going to copy this bit. Let's start, and we're going to plug that into then 2. Then we're going to go and grab our analog value, multiplied by float. We'll go 0.1. Then we're going to add it to our zoom value. Clamp that float between 0.1, 1, and then set the map zoom value to a new value. And again, I want a return node with a handled event at the end of this one too. So let's test this out with the current settings we've got. We will need to tweak some changes, but let's have a look at what changes we need to make. Push play. In my gamepad now, I push start button, go to my map screen. So immediately I can see that without moving the sticks, it wobbles now and then. And that's because we need to set up a dead zone for the thumbstick. Now, I move left and right, works just fine. But if I move the y-axis, that's me pulling down and up and it's going the opposite direction. So I want it to flip that around. And then we use the right stick to zoom in and out. Or did we not do that? So let's have a look. That doesn't work. Let's have a look what we've done. Yes, we need to change that to the right thumbstick. Right thumbstick in the y-axis. There we go. So immediately I need to switch. I know I need to switch the y-axis for the left thumbstick. So let's change that to -5 to flip it around. Again, you tweak this as best you like. Whilst we're here, we can also sort out the dead zone as well. So if I drag that analog value out and choose get, I can get a nearly equal float. And I'm going to check if it's nearly equal to a low number here. So if I want to leave it at 0, but I'll tweak up the error tolerance to 0.1, that means I have to have at least a 0.1 value change before it will detect it to be true, okay, as being equal to 0. So with that, we want to do a not boolean, and then make this an and, because we want these to both be true. Like so. We're going to do exactly the same down here too. So we can actually probably, no, we'll just copy and paste it. Keep it simple. Do the and. There we go. And we don't have to do it for this one. We could do, I guess, couldn't we? Might as well. Screw it. Do it here. Like so. Okay, so that's that done. We're going to close that. Push play. Let's test that out now. So my left stick no longer wobbles the screen, and so I move it. I move it left and right just fine. Up and down are fixed, and now my right stick can zoom in and out. So at the moment, I think my zoom is reversed. So if I push up on the stick, it zooms out. If I push down, it zooms in. And it makes more sense when you're playing it that you want it to be opposite the other way around. So let's just flip that again in our code here. I'll multiply it by -0.1. Hit compile. Now let's close this, push play. And now I've got a fully working map screen controlled by the thumbsticks. I can zoom in and out, and I can toggle back to my other values here. And that's it. We have successfully created a variety of menus, all combined together with our gamepad as a controller input. Alongside the mouse and keyboard, we're not neglecting it, it's just an additional input. So thank you very much for watching this series. Hopefully you've learned some things along the way. I know I certainly have. And hopefully you've enjoyed this series as a whole. If you like what I do and you want to consider supporting me, head over to patreon.com/Ryan Laley. Just like all these fantastic people have done, you can support me from just $1 to get access to all the videos early before anyone else, as well as a load of Patreon exclusive benefits too, like access to Discord, exclusive videos, and so on and so forth. Thank you to everyone for watching. If you haven't subscribed yet, make sure you hit that subscribe button to watch weekly videos released by myself, as well as weekly live streams. And of course, don't forget to hit that like button. Thanks very much everyone, and I'll see you all next time. Bye bye.